Today I demonstrate the Agentic Invoice Processor. This system prioritizes sustainable AI engineering. It uses efficient Gemini 2.5 Flash Lite agents for orchestration and extracting of complex time registration tables. But here's the twist. When data is missing or hidden in images, it triggers a tiered self-correction. It runs OCR, but then attempts zero-cost regex extraction first, using the LLM only as a last resort. For this project, I created 13 mock invoices with completely different layouts to test every edge case. The test cases are shown in the test matrix and we will quickly flip through them. As you can see, there was a lot of diversity. In this demo, we will examine 7 specific scenarios from the matrix and conclude with a fast-forward cloud deployment. Invoice 1. The happy flow. This is the baseline flow. Invoice 1 is recognized instantly by the universal processor. No OCR is needed. The text layer is extracted and the line item agent converts the table row into structured JSON, fast, cheap and deterministic. In phase 1, the invoice is accepted as the healthcare invoice and the case number is validated. The unique company details are detected like Chamber of Commerce and tax number. And in phase 2, where the agents come into play, we see orchestration picks it up, extracts the invoice lines and stores the extracted into JSON. It found all the company details and it also determined this invoice as a coaching invoice. And it detected all the cases where this profession is working on, including the hours and the date. In phase 3, we validate the results against the golden set. And as we can see in the result, the invoice was 100% correct. Invoice 2. Self-correcting logic. Now watch invoice 2. Since these letters are visually identical to 1 and 0, humans often mix them up on invoices. The system detects the ambiguity using fuzzy logic and automatically repairs the client ID case to match the valid database records. No human intervention required. Here we see the detection that it needs review, and here see our agents who repaired the problem. In our JSON output we can see the original text and the corrected text. The old 0 substituted by the correct O. Invoice 4. The tiered extraction. Here's the power of the tiered architecture. Invoice 4 has its metadata hidden in the footer image, which will standard extraction missed. The agents detect that critical data is missing, like the Chamber of Commerce and the VIT. It autonomously decides to trigger the Google Vision OCR tool. Once the text is recovered, it extracts the identifier immediately using regex, avoiding expensive LLM calls, speed and accuracy combined. And again, we have a 100% score. And our JSON, as expected, is filled correctly. Now let's have a look what just happened there. First, we imported the invoice and we noticed that we couldn't read the VAT and the KVK numbers. Then the orchestra engine recognized it that we were missing some important numbers, though it was redirected to the OCR. The result of the OCR came back and we tested again against the Regex engine. And we immediately had it successfully matched. Invoice 5. The gatekeeper. Now look at invoice number 5. There's something fishy about this. Let's see what our agents are thinking about this one. What we immediately see, the invoice is rejected. Why? Because the client case number was either unknown or ambitious. The sender must update the invoice to a valid client case number. Since the invoice is rejected, the agents are just dropping it and are not processing it anymore. It needs to be reviewed. Invoice 11. Complex logic. Finally, handling complex invoice 12 is a multi-page document containing multiple cases. The agent is not only handling columns, but now it also has to handle rows, as we can see here. Let's see what our agent will make from this one. Well, it looks like they have zero problem with it. 100% score. Well done. Correctly extracting all the company info and a long list of client cases they worked on. Invoice 12. Active and non-active cases on one invoice. As we can see on this invoice, it has several cases with 0 hours. So basically there's no work done on these cases. Let's have a look what our agent thinks about this one. It did a 100% match, and now have a look at the JSON. Yes, instead of hallucinating some numbers, it actually identified these empty cases and put them in the case list of no activity. And only one client case has hours booked on them. And finally, oh no, Invoice 13, an expensive consultancy bill for AI architecture. Let's see how this works out. The agent detects billable hours but 0 valid patient codes. It correctly rejects this for the clinical system. Instead, it flags it for a human in the loop, who can simply route it to finance for payment. This ensures that only valid therapeutic sessions enter the healthcare system, keeping our data clean. Cloud Run. Finally, to prove scalability, I deploy the entire pipeline with all 13 invoices to Google Cloud Run. We will fast forward this process so you don't have to wait all the time. You can see it executing now in the cloud environment. And at the end we can see it achieves the same exact 100% accuracy score. This confirms the solution is not only a local script but a reproducible cloud native architecture ready for production. Thank you for watching.